Here's a situation in which statistical modelling has an important role to play: conservation. Around the shores of New Zealand, there are maybe 3,000 or 4,000 hectares dolphins, which are vulnerable to extinction. Many dolphins live around the Banks Peninsula of the South Island, which has a sizable fishing industry. However, the gill nets the fishermen have been using can be potentially fatal to a dolphin. Since the late 1980s, a sanctuary has been set up around the Banks Peninsula, within which gill netting is tightly restricted, and hopefully that measure will help the dolphin population to survive. But how can you tell? Survival rates in animals are often estimated using annual recordings of individuals over a number of years. The full set of observations can be used to predict the survival rate from one year to the next in a combined effort between mathematicians and biologists. There are several ways in which an animal can be identified, but for this endangered species, the observations of individual dolphins have relied on photos of distinctive fin markings. The study was initiated in the mid-1980s by the Zoology and Marine Science departments at the University of Otago in Dunedin. And this work is being continued by marine biologist Stefan Brager.
My work depends very much on the weather. That means I try to go out as often as possible, which is on average every other day. And I always need someone to come along to help me, because while I take the photos, someone else needs to drive the boat. In theory, one could mark these dolphins, but their small population size and their endangered status prohibits any kind of invasive research. Therefore, taking photos of live dolphins are the only ways available.
David Fletcher is a biostatistician who was brought in to assist the biologists. There were several years of observational data to work on, but to determine whether the sanctuary is proving to be effective or not, needed the input of a specialist who could work on the modelling assumptions.
One of the interesting aspects about doing this work for me is that this sort of modelling is usually done in conjunction with my biological colleagues, and I will suggest certain things we can do, and they will tell me whether it's realistic or not.
I need the statistical input of a mathematician because the data that I gather in the field are very sparse, and sometimes I don't see an individual for a long time. And if I want to make any inference from these few individuals to the entire population, it requires a statistical model. And that's where David comes in.
You can build in functions to relate this probability of sighting or not sighting to weather and the behaviour of the dolphins. And this can be based on information such as how often an individual has been sighted in the past, and also, importantly, how much effort has been put into the fieldwork in different areas in different years. One aspect of the type of model we use here is that the sightings of dolphins are independent. We know this is not going to be true because we know that the behaviour of dolphins is such that it seems more likely that if one is seen in a particular year, then there may be one or more others that are also with it.
In fact, other studies, together with this data from Akaroa, have established that the common pairing of individuals won't upset the validity of the model. So just what have the statistics been able to say about the dolphin's plight so far?
The analyses we've carried out on these data that have been collected over the last 10 years suggests that the survival rate is around 86% for the adults. That means, in other words, 14% are dying each year. Given that the birth rate is not sufficient to compensate for this, it suggests that the population is in trouble. Ideally, that survival rate should be around the 90–91% mark for the population to be safe.
As the assumptions about the model are fine-tuned, then the predictions about the fate of the dolphins should become more and more reliable. From then on, it's up to the conservationists.
you.